Assalamualaikum and very good afternoon to all of you. Today, I would like to talk about a new topic, which is access control list, or abbreviated as ACL. So, in wide area network, ACL is one of the fundamental components of security. What is ACL? Um, it is actually a function on the routers that monitor incoming and outgoing traffic and compare it with a set of defined statements, which is the list. So basically, ACL work on a set of rule, and this set of rule is placed to provide a security to your network, right? So as shown in the diagram here, so basically we have um, three routing devices, which is R1, R2, and also R3. So now we can see that each of the routers has their own ACL statement. Okay, like router 1, we place the ACL so that no video can be accessed to S1, which is the switch network, and no access to S2 for S1, meaning here um, S1 cannot access S2. So, and then we have other ACL lists on R2 and also R3. So, basically here with ACL, you can actually filter packets for a single or group of IP address, or a single host or a group of network, right? So from the source to destination. So basically here in this example, okay, in this diagram, you can see that for ACL on router 2, okay, the rule is we can either allow or deny traffic. Okay, for example, in ACL number 2, we can either allow or deny traffic. Or we can also specify an access to a network, like in this case, the network on S1, okay, is not allowed to access the network in S2. Okay, so basically we can put a variety of statements, okay, variety of filtering onto the ACLs. Okay, so now if we see how ACL can be used to secure the network, so ACL can enable you to control traffic into and out of your network. So ACL is actually act as a stateless firewall. So if you do not have ASA firewall in your organization, so you can basically use ACL to control the traffic in and out of your network. So what ACL can do is it can permit or deny, okay, it can permit or deny network address, or it can also permit or deny a host address. So it can either permit or deny network address, or sorry, just go sorry, I accidentally go to the next slide. So it can either permit or deny network address, or it can also permit or deny host address. Meaning you can permit traffic to the whole network, or you can also permit or deny traffic to a single host, a single computer in the network. Maybe to a server or to a switch or to a printer. So it's either a network or a single host. But you can also permit or deny to several hosts. Okay, it depends on how you write your ACL rule. And the second part is you can also control network traffic. So control network traffic here means you can permit or deny based on the TCP or UDP port. Because we know that, okay, um, a packet may have different protocols such as TCP or UDP. So for TCP and UDP, you will have several services that falls under TCP or several services that falls under the UDP depending on your connection, whether it's a connection or connectionless oriented. This we will discuss further in the next slide. Okay, so and the third part is you can also permit or deny network traffic based on the network protocol used. So in here, the most common protocols is IP protocol, but we also have other kind of or other type of network protocol such as the IPX or routing protocol such as OSPF protocol, RIP protocol, EIGRP, or ICMP packet. So we can also filter based on the network protocol that's currently being used. So let's talk again to how we can monitor the TCP or UDP packet. Like for example, in this diagram, it is given that you can see the statement here is that in the ACL they want to allow email and deny telnet. So email and telnet, how we can filter it is we will filter based on the specific port associated with the service. Like for example, here for example, for email, we have three parts associated with it, which is we have the POP3 port. Okay, we have also the IMAP port for IMAP. So this is to receive. Okay, I can't really write here. Okay, I hope that you can understand. Okay, this is to receive. And then we also have another one, SMTP. Okay, SMTP services, which is to send, which is the protocol used to send the emails. Right, so this is all works on the TCP port like SMTP, which is port 35. And then we have the POP3 and also IMAP, which works on the port 110. So basically here, we can filter based on specific service. So if you were to allow email packet or traffic for email services, so you have to allow the port for POP3, port for IMAP, and port for SMTP. And this port is associated with the port number. So we have two kind of ports here, which is TCP port and also UDP port. So the port range is from 0 to 1023, but not every ports can be used because some of the ports is reserved to certain protocols, which I will show you later on in this class. Right, but a few of the well-known UDP ports is like port 69, TFTP, and also port 520, which is for the RIP protocol. And that goes for the TCP port as well. So we have the well-known TCP port. Like for example, if you want to permit or deny FTP services, so we use port 21. All right. So if you, like I said previously, if you want to allow email packet packet. Okay, so we use the port number 25. Okay, so we have port 38110, and then we have another one which is the port for the IMAP. So basically here, when we define if we want to permit or deny the traffic based on the services, we can either define the ACL statement based on the port number or the services name. Either one. Okay, either one. So you can either use the part number and also the application name or the services name. Right? So now, but there are some services or application that uses both ports, which is TCP and also UDP. So some of the well-known um, um, protocol or services that uses both is DNS and also SNMP. But like for DNS, you have the default ports, meaning if one is if UDP doesn't work, so they will use the TCP port. Okay, so basically now, how packet filtering happen in ACL? So packet filtering will control access to a network by analyzing the incoming and outgoing packet and parsing or halting them based on stated criteria. So these criteria are defined using ACL. So those criteria, we will go one by one later on. So we have the criteria later on. But the second thing that you need to understand is ACL works sequentially, right? So ACL works sequentially, meaning here, when they want to permit or deny statement, okay, they will go to the first statement, second statement, third statement. So hence the reason why when we would like to write an ACL statement, the statement here means the rule that you define. Okay, the first statement should go. You need to write it in a way that the first statement is the most specific statement in the list, and then the second statement, third statement, and when you are going towards the bottom of the list, so the statement or the rule should be more generic. Okay, so the first few statements should be more specific, and when you goes down to the bottom of the list, so it will be more generic. So if I were to write it, okay, so assuming that this is your list, ACL list, I just put the number like here. Okay, I put it 1110. I will explain why is 1110 later, but for the sake of this example, so 1110 is the extended ACL. So the first statement should be more specific, and when you goes down, okay, like for example, you have 10 statements, so it will be you need to write it to be more generic statement, because ACL is read sequentially. Okay, so if you have a specific statement, okay, specific statement like in this specific statement like if you were to block certain services, very specific, certain services like email or web, so it's more specific, Okay, but if you were to block or deny the whole network, so that is a generic statement. Okay, the more generic it is, so you need to place it at the bottom of the list, right? So now, the ACL can extract the following information from the packet header, but the packet filtering works at layer 3. Yeah, layer 3. Hence the reason why the permit or deny decision, okay, permit or deny decision is based on the source and destination IP address. And also you can also, because you also have the information of the TCP and UDP port, source port and destination port on the packet as well. So you can also have the permit and deny decision based on the port. But mainly it was on layer 3, so you need to have the source and destination IP address, right? So for packet filtering, I have mentioned earlier, you not only you can filter based on the TCP port or the network or host addresses, but you can also permit or deny traffic based on their network protocol. So we have various network protocol. The most common one that we use is, of course, we use the IP protocol. But because when you are doing network routing on the routers, because so of course you will deal with different kind of protocol as well. So you can also block based on the network routing protocol. Okay, so how do actually ACL is filtered? Sorry, the packet is filtered using ACL. So, for example, if we have two network, which is the first one here. Okay, the first one here is we have network A, and also the second network is network B. So, for example, network A can access the web HTML web, but network B cannot access the HTML web. So they will check. Okay, they will check. So for example, here I just put like network A 192.168.1.0, and then the network B is 192.168.2.0. So basically they will check this IP address on the header. Okay, if the network is 192.168, if the network is from 192.168.1.0, so if it's from network A, and then if it asks for port 80 is the port for HTML web. Okay, port 80 is the port for HTML web. So it will allow it. But if the services ask is beside the HTML web, so they will deny it. On contrary, we can see that if the network here is 192, in the packet, the network address is 192.168.2.0. So whether if they are asking for port 80 services, so basically they will deny it. If they are asking beside port 80 services, so basically they will allow it. How can we write the statement? Okay, all of this I will explain later on in the later part of the video. All right, so that's all for part 1. I'll see you in part 2.